All right, so next in line is this thing called the cosine rule. Obviously, it involves the cosine. Again, as for the sine rule, this can be used in any triangle. And having said that, we use it when our problem involves three sides and one angle. All right, so three sides and one angle. So if you got in your information, doesn't matter which one you're looking for, but as long as there's three sides and one angle involved in the question, then you use the cosine rule. Again, this is something you might use next year in the vectors stuff. And the formula is on the formula sheet that you get on the exam. All right, proof of it, if you really want a proof of the formula for it, then your textbook. But if you have a triangle, just like we did before, ABC, labelled same as had before, then there's three ones. So in this case, if we're after angle side A, and we've got the opposite angle here, angle A, and we've got these two, so if we've got these two sides and the included angle, and then you'd write it in this way here, so A squared equals B squared plus C squared minus 2BC cos A. All right, if it was these two sides you had and an angle B, then you can write it in this way, and if it's sides A and B you've got an angle C, then you write it this way. Now, of course, you can rearrange if you're finding, that's all very well if you're finding the side length, but if you're finding the angle, yeah, you can just use these and then you can rearrange, or you can use the rearranged version of the formula, which is there. All right, so if you're finding the angle, then you would be given all three side lengths. If you're finding a side length, then you'll be given two sides and the angle in between them. All right, so let's have a look and see how we might use it. So here we've got triangle ABC. And so here you see you've got two sides and the angle in between. All right, so and we want to know this other side over here, length of AB, which is opposite to C. All right, so that means the version we're going to use is C squared equals A squared plus B squared minus 2AB cos C. And so C squared then would be A squared, opposite A is 5, plus 10 squared minus 2 times 5 times 10 times cos 67 by the looks of it. All right, so you can stick all of that into your calculator. You don't need to work out each one individually. And when you do, you get 85.926 to 3 decimal places. But of course, we're wanting C, not C squared. So we then need to square root that. And when we do that, we get 9.269, and we are told we want it to 2 decimal places. So 9.2 and 7 when we round it up, and centimetres. All right, so there's how we go about finding a side. All right, the next, if we're wanting to find an angle. So it says find angle A. So we're wanting to find this angle down in here. So we're wanting to find angle A. And so when we find angle A, we're going to use this version here. All right, I could use this if I wanted to and then rearrange, but I'm going to use this where the equation's already been rearranged. Really doesn't matter which one you use. So the cos of A will be b squared plus c squared minus a squared over 2bc. So the cos of A. All right, B, remember B's opposite there, so 15. C squared opposite C, 6. Minus A squared opposite the A is 12. Over 2 times 15 times 6. And then you can work all of that out if you want. And if you did that, you'd get 117 on the top, and on the bottom you get 180. And then to get the angle A, you've got to use the inverse cos of 117 on 180. And when you do that, you get 49.46 degrees. All right. And so that's how you find the angle. Now, having said that you can work this out to get this, you can in your calculator, and your calculator would be just as happy for you. Again, using your templates and all the rest of it, you can put in this. You can put that into your calculator, and your calculator is quite happy with you doing that. So you didn't have to work that out there if you like. All right, so that's the cosine rule. So it involves all three sides, not 4 sides, all three sides, and one angle is what it involves. All right, so if you need any clarification on any of that sort of stuff, make sure you get some, and as always, have fun.